Alright, so we are moving on to 5-2, applying properties of rational exponents. So to save ourselves a little bit of time and you not having to listen to me so much, I'd like you to hit pause right now and go ahead and fill in this table that we've got here. And you can actually fill in up to example 4, and then we'll go ahead and work through those. So take a minute, do that, and then come back. Okay, so all of these properties are things that you've seen before. They are our exponent rules. Sorry about that. And now we're just applying them to fractional exponents, but the same rules still apply. So when you have the same base and you're multiplying, you just add those exponents together. So we do have the same base. 1/2 plus 3/2 is 4/2, which equals 5 to the second, which equals 25. 3, when you raise a power to a power, you multiply those exponents. So you've got 3 to the 5/2 to the second. Well, 5/2 times 2, those 2's would cancel out, and you would just have 3 to the 5th, which is 243, I believe. Yes. Okay. Here now we can kind of separate. So just like you can raise everything to the same power, you can separate those and raise them to the same power. So you would have 16 to the 1/2 times 9 to the 1/2. We now know that those mean square roots. So the square root of 16 is 4. Square root of 9 is 3. So that gives us an answer of 12. Negative exponents means we take the reciprocal and then apply the positive exponent to that. So that would be 1 over 36 to the 1/2. We know that an exponent of 1/2 means a square root. So the square root of 36 is 6. We would have 1 over 6. When we are dividing exponents, same base with exponents, we subtract those exponents. So this would give us 4 to the 5/2 minus 1/2, which is 4 to the 4/2, which is 4 squared, which gives us an answer of 16. Okay. All right, so when you raise a quotient to a power, so when you've got a fraction raising to a power, again, you can split those powers up. So you have 27 to the 1/3 over 64 to the 1/3. We now know that this is the equivalent of taking the cube root of something. I want you to just get in your head that anything to the 1/2 is a square root, anything to a 1/3 is a cube root. You've just got to know that at this point. And so if I take the cube root of 27, that would be 3, and the cube root of 64 is 4. Okay, this is something that you haven't really used with exponents, but we're going to start applying that. And it's just combining like terms. So, for example, if I had 2y to the first minus 5y to the first, I know that those are both y's. I can combine them. We usually just don't see a 1 on there. You would see 2y minus 5y and know that you can make that negative 3y. Not a big deal. You've been doing that forever. Same thing happens here. If I have the same base, same exponent, I essentially can treat that like its own variable, and I'm just subtracting the coefficients. So this would give us negative 3y to the 1/2. All right, so let's work through some examples. Here I've got same base, so I know I can subtract those exponents. So I have 11 to the 2/5 minus the 4/5. That gives me 11 to the negative 2/5. When I have a negative exponent, it means I need to take the reciprocal of the base, which would be 1 over 11 to the 2/5. Okay. Here I've got 120 to the negative 2/5, which means that's going to shift to the bottom and become actually, let's make this easier on ourselves. We have the same base. Let's do that one. I was looking at it individually instead of cumulatively. So I have the same base. I can just add those exponents together. Well, negative 2/5 plus 2/5 just gives me 120 to the 0, which I know is 1. So I can just change that to a 1. 7 to the negative 3/4 means I'm going to move that up to the top and change that to positive. So let's move this down here. So I have a 1 times 7 to the 3/4. So our answer would just be 7 to the 3/4. All right, down on number 3, we're going to have to move things around a little bit. That's okay. And this is a 1/3, not a 1/13. All right, so we've got x to the 2/5. Down here, I have x to the 1st. So we have to think about what that means. So we should just change everything to fractions, which would make it a little bit easier. My y's are in thirds. So y to the 1st would be the same thing as y to the 3/3. And then x to the 1st, I'm going to put that in fifths since my x is up here in fifths, so the 5/5, and then y to the negative 1/3. Remember that anytime something is negative, I'm going to move it, and then you're just asking yourself, so I'm going to move this up to the 1/3, and move that. Now you're really just asking yourself, do you have more of each base on the top or the bottom? So if I look at the x's, I have more on the bottom by 3. So in the denominator, I'm still going to have 3/5. Y to the 3/5. My y's are all now on the top. They're all positive. 3/3 plus 1/3 is 4/3. And I'm simplified. Remember that you still do not want, you don't want any negative exponents. And that should just be a way of doing things for you. Okay, I have x to the 2/3 and x to the 2/3, which means I can just combine my coefficients. That would just be 9x to the 2/3. Remember too that this 2/3 only applies to the x because that is not in parentheses. If it was parentheses 9x to the 2/3, then that 2/3 would also apply to the 9, but it's only applying to the variable or the number that's directly in front of it. Okay, so simplest form of radicals. Now we're just simplifying radicals like we have been, but now instead of always doing square roots, now we've got third roots going on, fifth roots, and third roots again. If you want to take a minute to write these down, let's do that. Okay, so we've got to think about here. We need 3 of the same number that multiply together to get 135, or as much of that as we can simplify out. So let's start to break this down. I know I can put 5 into 135, and that is going to go in how many times? So 5 goes in there twice, and 5 goes into 35 7 times. These are cube roots. Well, 27 is one of my perfect cubes. It would probably help you, I think we did in 5-1, to write down all of our perfect cubes. Perfect squares and perfect cubes are important for you to know, make it easier. So the cube root of 27 would be plus or minus 3. I cannot simplify that cube root of 5 any farther, so I'm just going to leave it just like that. And that is completely simplified. If you were to leave an answer like this is not simplified, and you need to have that simplified. Okay, let's go over to negative 81. So negative 81 I can break down into, I know I can take that into 3's, right? So I would have 1 negative 3, 3, 3, and 3, right? So I've got a positive if I multiply those, times 3 is positive, times 3 is negative 3 is negative 81. So I do have 3 positive 3's. So that is going to come outside with the negative 8. Within the radical, I still have that negative 3 sitting there, and now I just need to simplify. So your answer would be negative 24 and the cube root of negative 3. Okay. I didn't leave quite enough room down here, but we can make this work. So I know I can take 4 out of here. Let's think about if I can take 32, because I know that 2 to the 5th is 32. So it would be kind of nice if 192 was divisible by 32. See what we can do there. You can also take, let's see, so 5/2 root of 192. So it's going to have a radical in there, but let's see, 192 divided by 32 is 6. So that kind of helps. I know that my 5th root of 32, that's going to give me an answer of 2. And then I would have the 5th root of 6 left over, because we just determined that 32 times 6 is 192. And then I've got 8 to the 4th inside. So the deal is that you're looking at these like whole numbers, and what you're saying is, can I put 5 into 4? You're looking at them like you're reducing a fraction. I cannot put 5 into 4. So that 8 to the 4th, I don't have 5 a's to take out. I only have 4. So that's going to stay in. The 6 is going to stay in. This is going to simplify to a 2. So I'm going to have 2, and then the 5th root of 6a. Alright, moving on. So, same way that you have a square root that applies to any root, you can break up multiplication problems into 2 separate radicals. I suggest that, actually, and you can multiply them back to see if somebody's going to make it easier to simplify. Same thing with division. So, I might want to do that here. I need to find 3 of a certain number that multiply to 12 and 18 and the product of the two. So let's see. So if I'm going to break down 12, I would have 2 times 2 times 3. And I'm going to go ahead and put my 18 in the same radical. I'm going to put them together. So I know that in here I've got 9 times 2, and 9 breaks down to 3 times 3 times 2. So I'm looking, because it's third root, I'm looking for sets of 3. Well, the nice thing is I've got 3 to the third, I've got 3 3s and 3 2s. So that is going to simplify because I've got 3 of each of them. That's going to break down to 2 times 3, which is going to give me 6. Now, the other way you can do this, I want you to think about this. You've got 12 to the 1/3 times 18 to the 1/3. So you could actually multiply these two together. So you would have 12 times 18, right? And you've got 216. So you have 216 to the 1/3. Now, if you understand that you're taking cube roots of that, and if you've looked at your cube root numbers, 216 is a cube root. So if you take 3 second function, so that's the cube root of 216, you in fact get 6. There are going to be parts on your quiz that I'm not going to allow you to use a calculator, so you do need to know how to break down the roots. And I'm going to show you in class, Ms. Barnhart will also, that fractional exponents actually make simplifying quite a bit easier. Okay, so let's go to the 4th root, and you can divide this first. So I've got 80 divided by 5 is 16. So I can write this as one root as the 4th root of 16, and I need the same number that will multiply together to get 16. Same number 4 times. So 4 times 4 is 16, so that means I can break that down into 4 2s. So the 4th root of 16 is in fact 2. Okay, great. Alright, so moving along to the next page, and this is where we were talking about combining like terms. So I want you to envision, if you had this, it's really just like if you had 6k plus 5k, or 6x plus 5x, and that would just give you 11k. Exact same thing here, you're just combining those coefficients. So you would have 11 and the 5th root of g. Super easy. Alright, so there's some examples I want you to write in down here, and then try to simplify those, and then come back and check your work against what I've got. And I will have all the answers step by step, so if you get stuck on a part, you should be able to look at my steps and figure out where you're at. I'm going to show you on the first one how you can actually break this down into fractional exponents. So I know 96 is 16 times 6. And I'm going to rewrite these as fractional exponents just to show you what you've got going on. So you have 16 to the 1/4 times 6 to the 1/4 times n to the 7th to the 1/4. But that gives you n to the 7/4. So with the variables especially, what you're really doing is just reducing this fraction. Anything that's a whole number is going to come outside of the radical. Anything that is a remainder is going to stay inside the radical. So it's actually much easier to simplify these if you think of it that way. So the 4th root of 16 is 2. I can't take the 4th root of 16, that's not a whole number, so I'm just going to leave that one inside. With the variables, 4 goes into 7 once, which means I have n to the 1st, and I have 3 left over. So that's going to stay inside, with the 6. Okay, fractional exponents actually make that quite a bit easier. Here I've got same root, same radical, so I can just combine the first two, and I'm going to get -6 times the 4th root of 3. Here I just need to break this down a little bit. So I've got 3, the 4th root of 32 can get broken down into 16 times 2 minus 2 and the 4th root of 2. So the 4th root of 16 would be 2, so I'm going to bring that out here, get rid of that. That gives me 6 and the 4th root of 2 minus 2 4th roots of 2. Now I've got a situation where I can combine like terms. So I just get 4 and the 4th root of 2. And I'm going to give you the answers to the rest. Alright, so the key to these is really breaking down into things that are more useful. So I hope in the examples you can see I've done that. You're multiplying your exponents, especially with fractions, they'll cancel out and give you whole numbers. And we'll do much more practice in class. Thanks.